Good morning. My name is Samuel Nadir, KH20018. I'm from group 6. Now I'm gonna present about our lab module, which is batch reactor. And my group members are Nur Huda Ifa, KH20023, Nur Farhana, KH20031, and myself, Samuel Nadir, KH20018, Ama Anas, KH20051, and Nurul Husna KH20072, and I'm gonna explain about abstract. As you can see in this experiment, a batch reactor is used in chemical process on a small scale for testing new processes that have not yet been fully established for the production of expensive goods and for processes that are difficult to convert to continuous operations. A batch reactor's main advantage is high conversion, which may be achieved by leaving the reactor in the reactor for lengthy periods of time. But it also has the disadvantage of high labor expenses per batch and difficulty scaling up production. The reaction rate constant, activation energy, and order of reaction can all be determined by using a batch reactor. The liquid phase saponification reaction between sodium hydroxide and ethyl acetate was chosen for this experiment. That's all from me, and I'll pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurudaifa binti Husna. My ID number is KH223. Now I will present the methodology for this experiment. First, we're going to prepare for the preparation of the calibration curve for conversion versus conductivity. For the theory, the conductivity for each conversion value by mixing the following solution into the 100 milliliter of the nice water was determined, which for 100 milliliter sodium hydroxide for 0% conversion, next 25 milliliter sodium hydroxide plus 25 milliliter acetate solution for 25% conversion, 50 milliliter sodium hydroxide plus 25 milliliter ethyl acetate solution for 50% conversion, and 25 milliliter sodium hydroxide plus 75 milliliter ethyl acetate solution for 75% conversion, and lastly for the 100 milliliter ethyl acetate solution for 100% conversion. Then the calibration curve of conversion versus conductivity was plotted, and the slope and y-axis intercept was determined. Okay, next, for saponification reaction in the batch reactor. First, the minimum working was 2 liter. Then the conductivity of the reactor solution in the reactor changed with the degree of conversion, and this provide a convenient method for monitoring the progress of the reaction. In this experiment, conductivity values was recorded every 2 minutes by reading the value directly from the conductivity meter. The reaction temperature was set at 30 degrees Celsius and maintained by at a thermostat available in accordance with the instruction given in the operating manual, which is available near the apparatus. And then the same experiment was repeated with the temperature increase that was set at 50 degrees Celsius.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Anas bin Ahmad Sebaudim, and my number metric is KH20051. So I will present the result and discussion for the experiment. Okay, sodium hydroxide and ethyl acetate were used in this experiment to investigate the effect of temperature on the saponification reaction of both chemicals in batch reactor. Sodium hydroxide and ethyl acetate react to form sodium acetate and ethanol. Sodium acetate and ethanol are both non-conductive. However, because sodium hydroxide and ethyl acetate are both conductive, sodium hydroxide is a more powerful ionic compound than ethyl acetate. In a batch reactor, the reactants and catalysts are placed in the reactor, which is then closed to metal transport, and the reaction is allowed to proceed for a set period of time, after which the mixture of unreacted material and product is withdrawn. Okay, this is the result that we get for calibration curve. For 0% conversion, we get conductivity 15.7 and concentration of sodium hydroxide is 0.05. So when the conversion 25%, the conductivity decreased to 40.7 and the concentration to 0.0375. And for 50%, the conductivity is 12.5 and concentration is 0.0250. Conversion for 75%, conductivity we got 10.6 and concentration of sodium hydroxide is 0.0125. And the conversion 100%, we got conductivity which is 9.0 and concentration of sodium hydroxide is 0. So we plot the graph concentration versus conductivity. This is a calibration curve. A calibration curve of concentration of sodium hydroxide versus conductivity has been plotted on the basis of table 1. The slope of the graph can be calculated from graph 1 and it is 0.0071, while the y-intercept is negative 0.0634, and the trend of this graph is concentration of sodium hydroxide is directly proportional to conductivity. So to calculate concentration of sodium hydroxide, we use formula M1 V1 equal to M2 V2, which is M1 is initial concentration of solution, V1 initial volume of solution, M2 final concentration of the solution, and V2 final volume of the solution. And this is graph 2, conversion versus conductivity. So following that, a graph for conversion versus conductivity was created using data from table 1 2. From graph 2, it is possible to conclude that the graph trend is decreasing over time. As shown on the graph, the slope of that graph is negative 0.1414 and the y-intercept is 2.2675. The equation that we get from the graph 1 will be used to calculate the concentration of sodium hydroxide in temperature of 30 degrees Celsius and 50 degrees Celsius. Meanwhile, the equation formed from graph 2 will be used to calculate the conversion for both temperature.
Hi, Assalamualaikum. My name is Nur Husna binti Muhammad Karim Pang. My metric number is KH272. Okay, I will explain for the part of result and discussion for the batch reactor. Okay, in this experiment, there was two conditions. For the first condition is temperature at 30 degrees C. The volume of sodium hydroxide was 1 liter and volume of sodium acetate was 1 liter. Initial concentrate for both solutions are 0.1 mole per liter. Okay, this is the table of data for condition 1. We get concentration and conversion based on the equation derived in the calibration curve. This is the graph for conversion versus time. Okay, from the graph, we can conclude that conversion in relation to time for temperature 30 degrees C is increasing. As shown on the graph, the slope is 0.5154 and the intercept is 25.422. Okay, for condition 2 is where we use temperature at 15 degrees C, but the volume of sodium hydroxide, volume of sodium acetate, and the initial concentration for both solution was same as condition 1. Okay, this is the table of data for condition 2. We get concentration and conversion also from the equation derived in calibration curve. This is the graph conversion versus time for 15 degrees C. We can say that conversion in relation to time for temperature 15 degrees C is increasing. As shown on the graph, the slope is 1.8273 and the y-intercept is 24.167. Okay, when we compare these two graphs, we can say that the conversion for 15 degrees C is higher than 30 degrees C. Okay, it is because when we heat a solution in the batch reactor, the particle contained in the solution move faster and collide more frequently, which will speed up the rate of reaction. When the rate of reaction increases, the process only needs a little time to fully complete. So, it proved that using a high temperature also can accelerate the reaction rate. Besides increasing the concentration of reactant, using catalyst in the reaction, increase the surface area of reactant, and increase the pressure of reaction. Okay, next, I will talk about advantage of batch reactor compared to others. Okay, for batch reactor, the advantage we get is it gives high conversion. See, it is a closed system. Good for producing small scale of product, easy to clean, low contamination risk since the reactor in the closed system. Suitable for reaction that require long reaction time. Okay, for CSTR, the advantage of CSTR is continuous operating. Can be used for small and large scale of product, easy to clean, good temperature control, and easily adapt to two-phase run. Okay. The advantage for plug flow reactor is it is also continuous operation like CSTR. Used for large scale of product, high conversion per unit volume, have good heat transfer, and low operating cost. Thank you.
This is the application in chemical industries. For batch reactor, we use it for pharmaceutical production, fermentation, and small scale production. For CSTR, used for wastewater treatment process, loop reactor in pharmaceutical industries, fermenters which involve use of a biological catalyst such as brewing and hydrocarbon processing, and the last one PFR used in gasoline production, oil cracking, and the last is oxidation of sulfur dioxide to sulfur trioxide. And that's all for me. I'm Anas. Thank you.
Hi, I am Nur Fazana binti Yusuf. My ID number is AH20031. For my part, I will present about the conclusion and recommendation. The purpose of this experiment is to study the saponification reaction between sodium hydroxide and ethyl acetate in batch reactor. Second objective is to determine the effects of temperature on the extent of conversion. In a calibration curve, we conclude that concentration is directly proportional to conductivity. When the concentration increases, the conductivity also increases. Next, by plotting a calibration curve, we can also determine the relation between conversion and conductivity. The graph trend in our results is decreasing with time. For the graph conversion versus time at temperature, we conclude that the conversion for 50 degrees Celsius is higher than 30 degrees Celsius. However, the rate of fraction was affected by temperature. The higher the temperature, the higher the rate of fraction. It is because when the temperature increases, the particles contained in the solution move faster and collide into each other, then will speed up the rate of fraction. When the rate of fraction increases, the process only needs a little time to fully complete. So the objectives of this experiment, as stated above, is successfully achieved. Next, for the recommendations, a few steps how to improve the experiment very well. First, the apparatus should be cleaned by using the ionized water to avoid contamination in any process. Second, the experiment should be done in 3 different conductivity readings to get average and more accurate results. For the third, the conductivity rod must be clean. It is supposed to be wiped every time when samples being tested using the conductivity rod to get the accurate reading. That's all. Thank you.